Welcome to Section 2, Decoupling Your Architecture. Traditional infrastructures have chains of tightly integrated components. Each component has a specific purpose. When one component goes down, the disruption to the system can be fatal. Consider this example of a three-tier architecture for a web application that processes customer orders. Each instance in the web tier communicates with each instance in the application tier. And each instance in the application tier persists data to a back-end database. An instance failure in the web or application tiers would also cause failure in the persistence of some data. In a tightly coupled system, scaling is also impeded. If you add servers at one layer, you also need to connect them to servers in each connecting layer. Continuing the three-tier architecture example, an instance that's added to the web tier must then be connected to every instance in the application tier. There are several ways a system can be coupled. You should consider them when building distributed applications in the cloud. First, application-level coupling relates to managing incoming and outgoing dependencies. Platform coupling relates to the interoperability of heterogeneous systems components. Spatial coupling relates to managing components at the level of the network topology or the protocol. Finally, temporal or runtime coupling refers to the ability of a system component to do meaningful work while it performs a synchronous blocking operation. To help ensure that your application scales with increasing load and that there are no bottlenecks or single points of failure in your system, implement loose coupling. With loose coupling, you reduce dependencies in your system using managed solutions as intermediaries between the layers of your system. This way, both failures and component or layer scaling are automatically handled by the intermediary. We'll now consider the three-tier web application architecture again. You can implement loose coupling by adding load balancers in front of the web and application tiers to distribute traffic at each layer. If one server goes down, the load balancer will automatically direct traffic to the healthy instances. In the business use case of the order processing workflow, one potential point of vulnerability is saving order data to the database. If the business requires that order data must persist in the database, then various scenarios, such as a potential deadlock, race condition, or network issue, could cause the persistence of the order to fail. In this case, the order would be lost and you wouldn't be able to restore it. The key takeaways for this section include these points. First, tightly coupled systems have chains of tightly integrated components and they impede scaling. Another key takeaway is that you can implement loose coupling in your system by using managed solutions, such as elastic load balancing, as intermediaries between layers. Thanks for watching. We'll see you in the next video.